Hello everybody. So last time I have given you one class test, and today we will discuss the questions and we will try to find out the answers of those questions. So let us see the questions first. So the first question is, we have to write a recursive or iterative function in Python which takes one integer as input and returns the Roman equivalent of that number. Now, what is generally while we mention our class, that in which class you are reading, then we used to write in Roman. Now, what are the different rules which governs this, that we will find out first. Now, rules for writing Roman numerals are: when certain Roman numerals are repeated, the number represented by them is their sum. Like I've given you one example, that is I and I. If you write, then this is equal to 1 plus 1. It is repeated twice, and therefore the meaning of this one is 2. Similarly, I 3 times we have repeated. It means we will add it 3 times, and this is equal to 3. One more example I have given here, like x. You know the meaning of x. X means 10. So if I write it x, then it means this is 10 plus 10, and this is equal to 20. Now you have to keep in mind one thing. A note I have given here, you can see that no Roman numeral can come together more than 3 times. So you cannot write a statement in this way. That is, you are writing 4i and you are expecting that this will be equal to 4. This is wrong, totally wrong. Or you are writing 4x and then you are saying that this is equal to 40. This is also wrong. So you cannot repeat a particular numeral for more than 3 times. Now similarly, one more rule is there, that is V, L and D. You know that what is the meaning of V? V means 5, L means 50 and D means 500. These are not repeated. You cannot repeat it. Some other rules are also there, like when a Roman numeral is placed after another greater value, the value of the resulting numeral is equal to the sum of the numeral. Now see, you can see here, that is I have written here V and 3 times I. You know V means 5. So 5 plus 1 is 6, 7 and 8. This is equal to 8. And similarly, when you are writing XV, X means 10 and V means 5. So this is equal to 15. Now another rule is there, that is when Roman numeral is placed before another of greater value, the value of the resulting numeral is equal to the difference of the numerals. Like if you write IV, so I is coming, this is smaller, and I is coming before V, and therefore we have to consider this one as 4, because 5 minus 1, in this case we'll go for 5 minus 1. And similarly, you can see here, that is for 9 we used to mention I and then X. So 10 minus 1, this is equal to 9. So this is how we used to write the Roman numerals. When Roman numeral of smaller value is put between two numerals of greater value, it is subtracted from the numerals on right. Now you can see here that two greater values are there. Here it is x means 10 and v means 5. These are the two greater value, and in between a smaller value comes. It means the element that is placed on the right, from there we will be subtracting this one, that is whatever we have placed in between. It means 10 plus 5 minus 1, that is 14. And similarly you can see x means 10 and then this x means also 10, and from this 10 we will be subtracting 1. So this is equal to 19. And L, you know L means 50 and V means 5, and in between this I is coming. So this means 50 plus 5 minus 1. It means this is equal to 54. So these are the different rules which while you will be converting anything into Roman numerals, then you have to keep all these things in mind. Now few other things are also there that you have to understand in case of Roman. that is different alphabets are also used in case of Roman, and you have to understand all this. So how to write the program? For this purpose, what I have done, that I have created one list, and in this list some of the values I have placed. That is, the values are, you can see here, 1000, 900, 500, 400, 100, 90, 50, 4, 10, 9, 5, 4, 1. Now if you see each of the case, then you can understand it. This is coming in a pattern. That is, this is 1 9 5 4 1 9 5 4 1 9 5 4 1. If I consider the first digit only, so it is 1954 1954 1954 1, like this. Now different meanings are there. When we add 0, then it changes the meaning, like 1000. Now see, I have created the first list as R and the second one as R1. Now 1000, the meaning of 1000 is M, so I have kept it in 0th location of this particular list. What is 900? Sorry, 900. 900 means CM. How it is CM? Because M means 1000, and from 1000 we are subtracting 100. You know that 100 is written with this, that is C. Similarly, how to write 500? 500, this is equal to D. 400, it means this will be equal to CD. D means 500, and from here we are subtracting 100, that is 400. When you are writing 100, then you only write C. When you are writing 90, then you will be writing 100 minus 10. So this is how it is done. So this is repetition, so it is coming under some algorithm, which is why I have represented it in this way. Now if you write it like this, then I think writing program will become very, very easy for you. So hopefully you have understood this particular part. Now let us write the program of this one. So first of all, we will write the iterative version of this one, and then we'll go for the recursive version of Roman conversion. Okay, so let us write the iterative version of the program. Now you can see on the screen that I have already defined the function, and the way you have seen in the slide presentation that I have created two different lists, that is R and R1, and the values are stored in this part. So as to save some time, that I have written it earlier, and also the main part of the program I have given here. Now let us code it. We'll write the code of this one. Now for this purpose, what I will do, that I am going to use one string here. Now how to define this one? See this. Actually definition of Roman or Roman representation is nothing but it is representation of a string, and therefore this is the reason why I'm taking one string here. Now the next thing is that I'll be using one while loop. So the statement I'm using here is while n. You know the meaning of while n? While n means how long this loop will be executed. This loop will be executed till the value of n is greater than 0. The time when the value of n becomes equal to 0, less than 0, it will come out of the loop. Now inside the loop, what we will do, we will run another for loop. So for I in range, we will take it this way, that is 0 to length of R. So you know that in R, the list R, the total number of elements that is present here is 13, and therefore we are running the loop from 0 to 12. Now this loop is used specially for traversing through this particular list. So we are first of all visiting 0th compartment, then first compartment, then second compartment, and in this way we will reach up to 12th compartment. So this is the main motive behind this particular loop. Now inside this loop what we will do, that inside this loop we will test a condition here, and the condition is if the value of n is greater than or equal to r of I. Now I will explain the meaning of the program. Let me finish the program first. So whether the value of r is greater than n minus 1, and inside it what we will do, st is equal to st plus you can write here r1 of I. So this is, as you can see, that this is nothing but concatenation of string. We are coming out of the loop, so we will use a break statement, and finally when we will be out of the outer loop, so in this particular part outside the outer loop what we will do, we will go for a return statement and we will go for return st. Now let us understand this particular program, that how it is working. So this is the complete definition of the function, and as you can see that the first list that I have taken is having 1000, 500, 400, 190. Now the way we have seen, that is, it is coming in a very harmonic pattern, you can say. That is, first one is appearing, if you take only the, consider only the first digit, that is 1, then 9, then the next one is 5, then 4, then again 1, 9, 5, 4, then again 1, 9, 5, 4, 1, like this. Now if you include all the zeros, whatever is there, now 0 is changing the meaning of the entire thing, but the pattern remains same here. When I am applying 3 zeros, it means this is 1000 and this is represented through m. 900 means cm, m means 1000 and c means 100. It means you have learned earlier that in the rule part you have learned that if it comes on the left hand side, it means from 1000 we have to subtract 100. C means 100, you know, m means 1000, so 1000 minus 100. The meaning of 500 is d, so we have written here d. Meaning of 400 means cd. How it is cd? D means 500 and from there we are subtracting 100. Similarly, this is 100 and this is C. The meaning of 100 is C, and therefore we have written here C. Meaning of 90. C means 100 and from there X means 10, means we are subtracting 10 from here, so we are getting 90. In this way the entire list named as R1 is created, where we have placed the corresponding value. M means 1000 placed in the 0th location, 900 means CM placed in the first location, then 500 means D, it is placed in the second location, and likewise. Now take one example first. Suppose from this particular part the user enters one value and that value is 501, or any other value you take, like 100 or 101 the value is, or 103 suppose if the value is. So let us consider the value is 103 that is taken as input by the user. So the list is created, the string is initially blank, and then it is moving to this part of the program and testing a condition. I told you that the meaning of this one, while n, means while n greater than 0. If you are not comfortable with while n, then you can write while n greater than 0. The meaning is same. So 103 is greater than 0. If it is greater than 0, then it gets into this for loop. So in the for loop, for I in range 0 to length of r, it means the loop will be executed 12 times, and by this time it will be traversing through this particular list. The time when it is traversing through this list, in this particular part, it is testing a condition whether n, what is the meaning of n? N means 103 suppose. 103 is greater than or equal to r of I or not. I is initially 0, So it is checking here 103 is greater than 1000 or not. So the answer is no. Therefore the loop is further incremented, I is further incremented here. The value of I becomes 1 and it's testing 103 is greater than 900 or not. No. It is greater than 500 or not. No. Greater than 400. No. It is greater than 100. Yes. So the answer in this particular part, it comes as yes. So by this time the value of I becomes this 0, 1, 2, 3 and 4. It means it is fourth. The value of I is 4. So if it becomes true, then what happens? You can see in this particular part it is written st is equal to st plus r1 of I. So st is a string, as you can see here. St is equal to st plus r1 of I. So what is the value of I? Value of I is 4. So in the fourth position of R1, this is 0, 1, 2, 3 and 4. What is there? It is C. And therefore C is concatenated with ST. So keep in mind the value of ST is C. We have to add one more line in this particular part that I have forgotten. So I will be writing one more statement here. N is equal to N minus, we have to write R of I. So this is the statement I have added here. What is the meaning? So what is the current value of N? The current value of N is 103, and from here I am subtracting R of I. So the value of I is still 4. It means 103 minus 100. So the final value of N becomes 3. Now we are breaking the loop, and after breaking the loop it moves to this while loop again to check whether the condition is true or not. So the condition is while n. N means while n greater than 0, it means n is still greater than 0, it is again getting into the loop. So keep in mind the value of n is now 3. So I in range 0 to length of R, it means it will visit each and every compartment and will test whether 3 is greater than 1000 or not, 3 is greater than 900 or not, 3 is greater than 500 or not. In this way, it will reach up to this point. 3 is greater than 4 or not? Answer is no. 3 is greater than 1 or not? Answer is yes. So the condition is tested here, and then the previous value of ST was C, and with C it is concatenating R1 of I. So what is the value of R1 of I, or rather what is the value of I when this condition becomes true? Then what was the value of I at that time? The value of I was 12. So what is there in the 12th position of R1? In 12th position of R1 we have got I. It means the previous value of ST was C, and with C what is concatenated? I. This means ST becomes Ci, and here we are going for n is equal to n minus R of I. The value of n is 3 and 3 minus 1, so we are getting here 2. It is breaking the loop and again getting into this part and testing the condition while n. While n means n greater than 0 or not. Now again coming to this part and testing the condition that is traversing through the array. The time when it is traversing through the array, again it is testing 2 is greater than R of I or not. So 2 is greater than R of I becomes true at this point again. Means the value of, when the value of I becomes 12, at that point it becomes true. And the previous value of ST was Ci, and now with Ci, that is R1 of ith position value, that is I, is concatenated again. It means ST becomes Cii. Now in the next line, n equal to n minus R of I, it means in this particular position again we are subtracting 2 minus 1, that is 1 is the value of n. Again it is going back to this part and then testing 1 is greater than 0 or not. It is true, and then again it becomes true in this particular part, that is the condition, this particular condition becomes true in this particular part, means at the 12th location. and from here it is extracting again this one. The same process is repeated. It means st becomes c I I I. N equal to n minus 1, the value of n was 1, and from 1 is subtracted, and that is equal to 0. It is breaking the inner loop, and from here it is getting to this particular part where the value of n is equal to 0, so it will not enter into the loop further. And therefore, if I write here return st, it means it will return from here c I I I. Now let us test this program and check out whether it is generating correct output or not. So I am commenting this particular part, and then I will move this part slightly to the side, and we will print it directly on screen. So let us make a slight change in the screen. I will cut this part, and in this particular area, instead of passing I will be passing here 103. Now let us check that what output is generated by this particular program. So for output, I am increasing the size of the screen a bit so that you can see properly. Now running the loop here. Now you can see the output on the screen. The output generated here is CII. So it is concatenated in this way and generated. Now let us run the program using a loop so that all the Roman values are generated. So I am just indenting a bit, and in place of 103 I'll be using here I. Save the program and let us execute it. So we'll be running the program here. Now you can see on the screen that this is the output that is generated here. All the Roman numbers are generated. So let us modify a bit, and let us code it in a different way, the way we have written earlier. So I am pasting this particular part so that you can understand which it belongs to which particular value. Okay, now you can see 500 for D, 499 means CD, X, CII, this way it is generated, and this is the output that is generated on the screen. Okay, now you can check all the outputs here. These are the outputs generated. For 98, this is the value, this is 90, and this is 8. So in this way you can check the output. Each and every output is correct. So this is how you can convert a number to its Roman equivalent, and the program is written this way. So hopefully you have understood this particular part. Now I'm coming to the next part. The next part is the second question. The second question is all about Haley sequence. So we will write one more program here. Okay, for the second program, we will first of all go through the question. The question is, write a recursive or iterative function which takes a number n as function argument and displays the Hailstone sequence of that number. The display should stop when the sequence reaches 1. Now, there is no such proof that Hailstone sequence always ends with 1. But it has been tested with most of the number. In most of the cases, it's not in all the cases, in fact, so far tested, whatever number we have used so far, all the cases it stops there. So we are considering here that 1 is the stopping point here. Now the definition: Hailstone sequence of a number can be generated from a starting positive number n by, if n is 1, then the sequence ends, and if the n is even number, then the next n of sequence is n by 2, and if n is odd, then the next sequence is 3 into n plus 1. So this is known as Haley sequence. Now you can see some of the Hailstone sequence that is given here. That is, if I take 7 into consideration, then the next number that is generated is 3 into 7 plus 1, and then we are getting 22. So 22 is even, so we have to divide it by 2. So we are getting 11. 11 is again one odd number, so 11 into 3 plus 1. So we'll be getting 34. 34 is again even number, and therefore we will divide it by 2. 17 is the odd number, and therefore we will again go with 17 into 3 plus 1, and in this way this number is generated, that is 52 is generated. So in this way the steps are repeated. How long it will be repeated? Unless and until we are getting 1. So you can see that from whatever number we start, ultimately it converges to 1. So in all the cases it converges to 1. So let us write the program of for this one. So for this we will write a function. Let us go to the code part of this one. So the coding of this one comes in this way. So I'm defining a function here. Let us define, that is Hailstone sequence. So I'm using here h as the function name and n is the argument that is used. Now in this particular case, what we will be doing, we will be using one while loop, and we will write while n greater than you can say 1. Now inside the while loop, this is a very simple program. If you write the iterative version of this one, so this is pretty simple program. So we'll be writing here one statement, and that statement is print n. So print n is the statement, and if the now we will be testing one condition here. So first of all, whatever number we have taken, we will be displaying that number on screen, and once the number is displayed on screen, now we'll be testing a condition here. The condition is tested in this way: whether the value of n modulus 2 is equal to 0 or not. It means we are testing here whether the number is even number or not. If the number is even number, then the value of n, we will change the value of n, that is n is equal to n divided by 2. So we will change the value of n like this, and if it is not, so we will take the else part of this one. So I am taking or defining the else part of this one. So else n is equal to 3 into n plus 1. So this is the code. This is a very simple program, simple and ordinary program. So one more thing we'll be doing. So this is the program. Let us now write the main program and see whether it is okay or not. So I'm demarcating it here like this, and then we will write the main version of this program. So the main program comes in this way. It is generating the number. It is a void type function taking only one argument. So the only thing is that we have to call this function. So I'm calling this function. HS is the name of the function, and let the starting point is 9. So we'll pass 9 from here, and we will see whether it works with this one or not. So I'm removing the previous output from here, and will slightly increase the size of the screen so that you can see the sequence here. Let me save the program first. So I'm saving it with this name. Okay, so I'm saving it with this name. Now we will run the program and see whether it is okay or not. Now let us run the program. Now you can see here that it's starting from 9, then 28, 14, 7, then all the numbers are generated, but the last number we are not getting as 1, rather it is 2, because the print statement is given inside. So what we will do, we'll give one more print statement. The last value of n is not generated here. So the time when I'm coming out of the loop, I'll be using here print the value of n. So save it and let us run the program again. Okay, now you can see here that 9, 28, 14, 722, all the values are generated the way it is represented there, all the numbers are generated as output. So this is Hailstone sequence. I hope that you have understood the program. This is a pretty simple program, and hopefully that all of you have completed this program in class test. And the recursive version of this one, as I have taken a lot of time here, so I'll be discussing the recursive version of the Roman as well as the Hailstone sequence in my next video. So I hope that you have understood this particular part very nicely, and if you are having any doubt or any problem, then you can directly write to me. So thanks.